The focus of this video will be to define what a type 2 binary non-acid ionic compound is and to work through multiple problems going from name to formula. For the most part, a type 2 binary non-acid ionic compound consists of a metal with multiple possible charges that is combined with a single non-metal. Okay, let's focus our attention in this periodic table. While some transition metals and metalloids can have one common charge, many can have multiple possible charges. For the simplicity of an introductory chemistry class, all transition metals, along with the two metalloids, Antimony and Germanium, found within the blue region, of course, will be treated as a type 2 cation. The only exceptions are the ones shown here in green. Those are considered a type 1. So in summary, if it falls under the blue area, it's going to be considered a type 2 cation. And remember, a type 2 cation is going to compose a type 2 compound. So because many type 2 metals can have more than one possible charge, a Roman numeral is placed in parentheses after the metal name to indicate the charge of the metal cation, just like you see in this example. So this charge is being represented with parentheses and then a Roman numeral inside of it. And by the way, these are some important Roman numerals to remember, going all the way from 1 to number 7. Let us now work this example going from the chemical name to the chemical formula. By looking at this compound, I can tell that it's a type 2. Why? Because the cation falls within the blue region. It's copper, if it's found right here. So the first step is going to be to write the chemical symbols and their charges. So the symbol for copper is Cu, the symbol for bromide is Br. And remember that the charge for the metal is the Roman numeral inside the parentheses, meaning this one right here. So I'm going to write a 1 plus. And for bromide, remember it derives from bromine, and it's going to be a -1. The second step reads, if both charges have the same number, write the elements together to make the formula. So they have the same number. I'm not worried about the charges. And that is my chemical formula. Okay, now let us look at lead 4 chloride. I know this compound is a type 2 because the cation is found within the blue region. It's Pb, its chemical symbol. The first step is to write the chemical symbols and their charges. Chloride is Cl. And remember that the charge for the metal is the Roman numeral inside the parentheses. If you're not familiar with that number, it's the Roman numeral number 4. And Cl is on group 17. It's a -1. The second step reads, if both charges have the same number, write the elements together to make the formula. Different numbers. I need to move on to the next step. If the charge numbers are different, create a T-chart. Then cross multiply by transferring only the numbers. The 1 is going to come over here. The 4 is going to come to the right side. Then we need to make sure the total charge of the compound balances to 0. 4 times -1 gives me -4. 1 times 4 gives me 4. So that balanced to 0. Step 4 is to be able to obtain the formula, we need to remove all the charges and keep only subscripts of 2 or higher. I'm going to bring this over here, and I'm going to keep that. That is going to be my final chemical formula. Okay, so now we're looking at gold 3 oxide, and I know this compound is a type 2 because the cation falls within the blue region, Au. And I know the charge for my cation is going to be a 3 plus. And I know I have oxygen, and oxygen is in column 16. It has a -2 charge. My numbers are different, so I'm going to create a T chart. I'm going to bring the 2 over here, the 3 over here, and I'm going to make sure that this compound balances to 0. 3 times 2, 3 times -2 gives me -6. And 3 times 2, 2 times 3 gives me 6. 6 minus 6 equals 0. Now, to obtain the formula, I have to remove all charges and keep only subscripts of 2 and higher. I keep both of them. Bring the O down, and then the 3. And this is going to be my chemical formula. Okay, so now we're looking at antimony 5 chloride. This compound is a little bit different. Why? Because the cation, instead of being a metal, it's a metalloid, but it happens to be one of the ones that I told you to remember. And antimony is right here. Its chemical symbol is Sb. So the first step, remember, is to write the chemical symbols and their charges. I know I'm going to have 5 plus. My chloride Cl, 1 minus. My numbers are different. I have a 5 and I have a 1. So I'm going to create a T chart. I'm going to bring my 1 over here to the left side. I'm going to bring my 5 to the right side. Now I need to make sure that the compound balances to 0. So 5 times -1 gives me -5. 1 times 5 gives me 5. And 5 minus 5 equals 0. So now to be able to obtain the formula, we need to remove all the charges and keep only subscripts of 2 or higher. So I'm going to bring Sb, which is antimony. I'm not going to write that. I'm going to bring Cl, which is chloride, and I'm going to bring the 5. And this is going to be my chemical formula. This compound is also a little bit different because the cation is a metalloid, Ge, which is the other one that I told you to remember. So I'm going to write their chemical symbols and their charges. I know this number is going to be a 4 plus. Why? Because that is a Roman numeral for 4. This is going to be a 2 minus. I'm going to create my T chart. I'm going to cross multiply. 4 times -2 is -8. 2 times 4 is 8. Right here, I'm still not done. Why? Because only if all subscripts have a common factor greater than 1, you have to divide all subscripts by the greatest common factor to obtain the lowest whole number ratio. So once you divide the 2 and the 4 by the greatest common factor, which is 2, you're going to get this right here. And that is going to be your answer. 2 divided by 2 gives you 1. 4 divided by 2 gives you 2. So that is your answer.